Hello everybody, welcome back. We are still on section 1.1 arithmetic sequence. We are continuing where we left off the other day. We are on page 7, question number 2 of the application questions. Let's read the question. Hugh works for a horticultural company. She plants flowers in rows. The number of flowers in each row forms an arithmetic sequence. There are 58 flowers in the 8th row and 107 flowers in the 15th row. Determine algebraically the change in the number of flowers between each row. So this is an interesting question, and what we're going to have to do is we're going to have to go back to grade 10 for a minute, because if you set this up, you'll notice that there's two pieces of information here. We have the 8th row, which tells us there's 58 flowers, and we have the 15th row, which tells us that we have 107 flowers. So what I'd like to do first is I'd like to set this question up, and let's write some information down that we have. So the first thing we have is we have n is equal to 8. That tells us that it's the nth row, the 8th row, and in there we have 58 flowers. So that's the last number. We're going to call that the nth term, so the essentially the 8th term, and that's going to give us t n equals 58. All right, that's all we have. So if we fill that in, we know that there's 4 variables in our formula. However, we need to have at least 3. But there's another set of information. We know that we have another value of n equal to 15, which would give us t to the n equals 107. So to be more specific, because we know we can't have the same number here, these are two separate pieces of information that is going to give us two different equations. All right, because they're the same information, but it's in the same problem. So what we need to do is we're going to try to determine by plugging this in, what do we do here? Well, first, if you look at it, we're going to write our formula. So I'm going to grab our formula right there. We have t to the n is equal to t1 plus n minus 1d. So we don't have d because we don't have the terms. So we know that the 8th term is 58, and we know that the 15th term is 107. So when we plug it in the first form, we got 58 equals, first term we don't know. That's the issue. However, we know that the first term is going to be the same in both. Plus n we know is 8, so it's going to be 8 minus 1, and d we don't know. So those are the two terms we don't know, those two terms. Okay, so that's where the second part of the information of the problem comes in. We have another n. So again, we're going to use the same formula. And we're going to plug in what we know. We know we have 107 equal to, first term, again, we don't know. We just recopy that. We do, however, know that it's equal to, plus 15 minus 1 times d. So we'll simplify this a little bit. So here we got 58 equal to, and again, we just recopy this, and 8 minus 1 would be 7d. So we have 58 equals t1 plus 7d. Do the same here at the bottom, the second equation. And again, 15 minus 1, we'll just subtract those and get 14. Just simplify it. That's all we can do. So now we have two formulas with two unknowns. So this might bring you back to grade 10 for a minute. At the end of grade 10, we learned that when we have two equations with two unknowns, we can solve this using what's called a system of equations. Some of you are like, oh, okay, perfect. So the first one here, we'll call this equation 1, and the second we'll call this equation 2. So these are, it's really nice. These are already set up for you really nicely. And the reason is, so I'll just call this equation 1, and I'll call this equation 2. You may remember me doing that in grade 10, or your teachers doing that. So we could use two methods. We have substitute. We could graph, of course, but we have substitution and elimination because we're doing this algebraically, as it mentions here. You'll notice that the T1 in both equations has a coefficient of 1. So it's already set up for elimination, which is excellent. So I'll do equation 2 minus equation 1. Now again, you could do 1 minus 2. It's not going to make a difference. The only reason I'm doing that is I know I'm going to end up with positive values. That's the only reason I'm subtracting equation 1 from equation 2. Only reason. So I'm going to take equation 2. Oh, sorry about that. I'm going to write it out because it's being a little fidgety here. So 107 equals T1 plus 14D, and then underneath that I'm going to write 58 equals T1 plus 7D. So what I'm going to do is I'm going to subtract them. So when you subtract them, if you do recall, you subtract every term in the equation, and you end up with, so again, we can only subtract like terms. So we have our constants we're going to subtract, we have our T1s we're going to subtract, and we have our D's, our common difference with the coefficient we're going to subtract. So when we take 107 and we subtract 58 from 107, we end up with 49. When we take T1, we subtract T1, that's eliminated. That's why we did it. This is called elimination. And then we take 14D and subtract 7D, and we end up with 7D. And then we divide both sides by 7, and we get 7 equal to D. So this tells us that our common difference is going to be 7. And we're finished with our common difference, because that's what the first one said. We want to determine the change in the number of flowers between each row. So the A part's finished. The answer is 7. Now if we go to the B part, it says determine using the general term for the sequence the number of flowers for the first row. So essentially we're trying to figure out what T1 is. Now you may remember from grade 10, once you had the one of the variables, remember we did X and Y, well in this case we have D. Once you have D, we can find T1 by substituting into equation 1 or 2. It's not going to make a difference. They're going to be equal. If you want to make sure it's correct, if you plug it into both, you verify that it's going to be equal for both. So plugging D in here will give you the same T1 as it will in the first equation. I'll do both just to show you that. So the first equation, well, I'm going to copy it, see if it'll work this time for us. Copy. Yeah, perfect. There's equation 1. We know that D is 7. So what we'll do is we'll plug in 7 for D. So we end up with 58. Oh, sorry about that. We end up with 58 equals T1 plus 49. Subtract the 49 from both sides, and you end up with T1 is equal to 9. So the first term in this arithmetic sequence is 9. So that means there's 9 flowers in the first row. And again, I'll just verify that again. I know you remember this from grade 10, but if you use the either equation would have yielded the same answer. And again, I'm just going to show you that that's the case. Plus 14 times 7, that will give us 107 equals T1 plus 14 times 7, we know is 98. Subtract 98 from both sides, and once you subtract 98 from both sides, you're left with 9 equals the T1. So both will provide us with the first term. Again, you only have to do it once. You can pick either equation, but showing both will verify that it's definitely right. It's nice to know that you're right leaving the question. All right, so that's it for number 2. Let's move on to the next question. So I'm going to we're going to wait a minute. We're going to switch to the next video. So we'll see you again soon. Thank you.